In this question, our goal is to calculate the first 8 terms of the series. Well, we want to know what the partial sum look like and does it appear convergent or divergent? Remember the definition of partial sum. The partial sum is denoted by S sub n, which is the summation of a sub I starts from 1, goes to n. So that's how you define the partial sum. S sub 1 is equal to a sub 1. S sub 2 is equal to a sub 1 plus a sub 2. S sub 3 is a sub 1 plus a sub 2 plus a sub 3. And you can continue this process. We're going to use calculator to do calculation here a little bit because it takes time to do this using common denominator and regular algebra that we're doing. So let me just put some dots here. So S sub n is equal to the summation of 1 divided by I to the 4th plus I squared, and I starts from 1 and goes to n. We want to calculate S sub 1. S sub 1 is equal to 1 divided by 1 to the 4th plus 1 squared. So wherever you see I, you're going to substitute that by 1. So basically, S sub 1 is 1 divided by 1 plus 1 or 2. S sub 1 is nothing but 0.5. This is my first value, S sub 1. What about S sub 2? S sub 2 is equal to S sub 1 plus, so let me write down everything. This is the summation. I starts from 1, goes to 2 of 1 divided by I to the 4th plus I squared. So when you plug in 1, you get 1 divided by 1 to the 4th plus 1 squared. And when you plug in 2, you get 1 divided by 2 to the 4th plus 2 squared. But this quantity is already the one that you had from S1. So you already have S1. S1 plus this new quantity. So here you have 0.5 plus 1 divided by 16 plus 4, or 0.5 plus 1 divided by 20. So let me use a calculator and calculate this number because it takes time. So in using your calculator, S sub 2 becomes 0.55. So this is my second value. So far, I see S1 is 0.5, S2 is 0.55. I need to calculate some more terms to see where does this guy approaching. Now let us calculate S sub 3 or S sub 3. What do I have? I have the summation. I starts from 1, now it stops at 3. 1 divided by I to the 4th plus I squared. So with the same process, we plug in 1 for I, then we plug in 2 for I, then we plug in 3 for I. So you get 1 divided by 1 to the 4th plus 1 squared plus 1 divided by 2 to the 4th plus 2 squared plus 1 divided by 3 to the 4th plus 3 squared. But please pay attention here. This quantity is S1. And adding these two together, you had S2. So you already have S2. Just copy S2, which is 0.55, plus 1 divided by 3 to the 4th plus 3 squared. Let us use a calculator to calculate this S sub 3. Okay, I'm going to try to round it to a number. Okay, this is going to be 0.5611. 0.5611. Okay, this is my third value. And the question says find the first 8 partial sums. Okay, let us continue this process. Now let us calculate S sub 4. S sub 4, as you see, is the summation of 1 divided by I to the 4th plus I squared. I starts from 1 and stops at 4. If you break this guy down term by term, this is basically 1 divided by 1 to the 4th plus 1 squared plus, if you plug in 2, you get 2 to the 4th plus 2 squared. If you plug in 3, you get 1 divided by 3 to the 4th plus 3 squared. And now if you plug in 4, you get 1 divided by 4 to the 4th plus 4 squared. But again, please pay attention here. This is your S1. The summation is S2. The summation here is S3. You already calculated S3. Just use it over here. Get 0.5611 plus 1 divided by 4 to the 4th plus 4 squared. Okay, let us use a calculator to see what is this number approaching to. This is about 5648. Hope our calculations are all correct. This is the 4th sum. So far you have 0.5, then 0.55, 0.5611, 0.5648. And let us find the next partial sum, which is S sub 5. S sub 5 is the summation of the first 5 terms. This is 1 divided by I to the 4th plus I squared. I starts from 1, now stops at 5, which is equal to the same process. You get 1 to the 4th plus 1 squared plus 1 divided by 2 to the 4th plus 2 squared, 1 divided by 3 to the 4th, 3 to the 4th plus 3 squared, plus 1 divided by 4 to the 4th plus 4 squared, plus 1 divided by 5 to the 4th plus 5 squared, which is with the same argument. Guys, you have S1, you have S2, you have S3, S4, the 4th partial sum, and now you're adding S4 to the new term, 5 to the 4th plus 5 squared on the denominator. S sub 4, you already know this guy is 0.5648 plus this fraction. Let me move it a little bit here, so we have enough space to write down everything. 1 divided by 5 to the 4 plus 5 squared, which is, let me use my calculator, see what is S5. It's about 5663.63. Very good. Okay, so far I see I have a lot of repetition of 0.56. Okay, let us find the rest of the terms and then make a conclusion. So I'm not going to copy everything down again. S sub 6 is the summation of the first 6 terms. I to the 4th plus I squared. I start from 1, goes to 6. You already know it is going to be S sub 5, which you already calculated here, plus the new term A sub 6. So you have 0.5663 plus 1 divided by 6 to the 4th plus 6 squared. Now, if you use your calculator, this number, let me type everything. S of 6 is going to be 0.5671. 5671. So let us find the next sum, which is S sub 7, which is the summation of 1 divided by I to the 4th plus I squared. I starts from 1 and stops at 7, which is going to be S sub 6 plus A sub 7, or you calculated this guy here, 0.5671 plus A sub 7, which is 1 divided by 7 to the 4th plus 7 squared. Okay, let's take a look at our calculator here. Your S sub 7, 5675, 5675. And finally, the last sum, S sub 8, which is the summation of 1 divided by I to the 4th plus I squared. I starts from 1, goes to 8, which is the partial sum of the first 7 terms, S sub 7, plus the last term, which is A sub 8. Very good. Let's use this number, 0.5675 plus 1 divided by A to the 4th plus 8 to the 2nd. Okay, what does our calculator say about S5? S8? S8 is going to be, let's see, 0.5677. Okay. So let us list all of these numbers that we calculated. This is our new sequence, am I right? So we are listing the sequence S sub 1, comma, S sub 2, comma, S sub 3, comma, S sub 4, comma, S sub 5, comma, S sub 6, S sub 7, S sub 8, and then the rest of the numbers. So my S sub 1 is 0.5. This is 0.5. The second sum, S sub 2, is 0.55. S sub 3 is 0.5611. S sub 4 is, let's see, 0.5648. 48. S sub 5 is 0.5663. And S sub 6 is 0.5671. And then S sub 7, 0.5675. And S sub 5 is 0.5677, and the rest of the terms. So this is your sequence that you're looking at. The question is the series S sub n approaching a unique numerical value? Well, just compare these. 0.5, 0.55, 0.5611, 0.5648, 0.5663, 0.5671, 0.5675, 0.6677. So it looks like it is a convergent sequence. This sequence is converging to 0.57 probably. For an exact numerical value, we have to do the actual calculation. But the answer here is yes. Our sequence is approaching, is getting closer and closer to a unique numerical value. It's not diverging, it is converging. Unique numerical value. So it is a convergent sequence. So what's the meaning of that for our series? And you're going to say that since the sequence of partial sum S sub n that you defined as the summation of 1 over I to the fourth plus I squared, I starts from 1 to n, has a unique numerical limit. This limit of S of n as n approaches infinity is equal to a numerical value like L. We don't know exactly what that number is. I'm guessing 0.57, something like that. So it means that the series summation of 1 divided by n to the fourth plus n squared, n starting from 1 goes to infinity, is also a convergent series. So that's the meaning of that for our series. We look at the partial sum and we calculate the partial sum for the series, and then if it's converging, we say that, hey, the series is a convergent series. Otherwise, it's going to be divergent. So take a look at everything. It's a quick recap for you. Question says, calculate the first 8 terms of the following series. The series is defined as the summation of 1 divided by n to the fourth plus n squared. The partial sum is defined as S sub n, which is the summation of 8 i's. I start from 1 goes to n. We build a sequence. This sequence has the terms S sub 1, which is A1, S sub 2, which is A1, plus A2, S sub 3 is A1, plus A2, plus A3. And as you saw, this can be written as S1 plus A2. This one can be written as S2 plus A3, and continue this process. So since we defined the partial sum as the summation of these general terms, S1 is 1 divided by 2, or 0.5. S2 is the summation of S1 and A2, which is 0.5 plus this fraction, it gives us 0.55. And since S3 is equal to S2 plus the third term, A sub 3, this is equal to 0.5611. Then we calculated S4, which is, again, now you have S3 plus the fourth term, A sub 4, and you continue this process. You calculated the first 8 partial sums. So if you look at the sequence itself, the very first term of the sequence is S1, the second term of the sequence S2, S3, S4, and so on. But S1 is 0.5, S2 is 0.55, S3 is 0.5611, S4 is 0.5648, S5 is 0.5663, S6 is 0.5671, S7 is 0.5675, S8 is 0.5620. I'm sorry, 77. So it's look like that your sequence Sn approaching a unique numerical value. To find that exact value, we have to do the exact computation. But looking at the behavior of this series, the partial sum it looks like the partial sum is getting closer and closer to a unique numerical value. So since the sequence of partial sums has a limit, what's the meaning of that for the series? It means that the series itself is a convergent series.